Okay, so I'm going to look to modify this last program we just did. Should be a little quicker. We just want to modify the method in multiples of to accept an integer parameter and generate the numbers between 0 and 1,000 until that number is a multiple of the particular integer that we accepted as a parameter. In other words, not just a multiple of 10, but a multiple of any number. So I want to go back to our code, and essentially I want to copy all of this code. So I'm just going to copy all of it. And then I'm just going to create a new class, multiples of 3, so that people can see the progress of this method or this class over time. I'm not going to put anything in it, so I'm not going to collect that because I want it to be empty, so I can just paste in here the code I just copied and just change it to multiples of 3. Space in there. Okay. Okay, so this is exactly the same code that we started with in multiples of. I just changed the name, or I copied and pasted, and now it's saved as multiples of 3. So what I want to do is I want to change this method so that it has a parameter of an integer n. So we're going to send in here, let's say we send in the parameter 10 in this instance, meaning we're still running the same code basically. But then I would have to say here I'm accepting an integer and we need to give it a name. I've already used n. Let's use d or divisor, D-I-V-I-S-O-R. So randomly generate the number, and then while n mod the divisor does not equal 0, print the number and generate another one, and then return n. So now the precondition, again, there are no precondition. Well, precondition is that we're the divisor is an integer. It does have a preconditioner, and now it returns an integer that is a multiple of that divisor. So notice this code, with that slight modification, actually runs exactly the same, because we're finding an integer, randomly generating numbers until we find a multiple that is an integer of 10. But if we think about sort of changing the code as a whole, we might need to define a new integer here. Let's make it, in this case, 10. So I'm kind of hesitant to use divisor again. So I think what I'll do is downstairs use divisor, and upstairs inside the method use d. So I would make my precondition that d is an integer. And we need to make sure that n is divisible by d, so that I can sort of downstairs use the words divisor and number, and by downstairs I mean in the main method. And in these other methods I'm using d and n, n for number, d for divisor. Okay, so and now we would call multiples with that divisor d. Divisor here. Okay, so this again, it's going to run exactly the same. It's just that now we could change this divisor to say 3 and run it, and you're going to see a problem here. Hopefully you see the problem. Randomly generates numbers until the number that we get is a multiple of, but 468 is not a multiple of 10, it's a multiple of 3. So what we need to do is we need to check that our number here, our output results, needs to also know what number we're dividing by. So we not only need to send it the number, but we need to also send it the divisor. And then upstairs in output results, it has an integer n, an integer d, and we have the number %d is a multiple of %d n comma d in our printf statement. So this use of d is probably not the best because I have a d variable here, but that's okay. This is the syntax required for the printf statement. Let's run it, see what happens. Oh, that was the first random number, hopefully. 582 is a multiple of 3. One way to check if numbers are multiples of 3s is to add the digits. So 5 plus 8 is 13, plus 2 is 15. 15 is divisible by 3, so is 582. Run it again. 81 is a multiple of 3. It's odd that that would be printing, it's only printing the one number. Oh, there's the, okay, so it did, oh, well, sure, because a lot more numbers are divisible by 3, so oftentimes you're not going to get very many. 468 is a multiple of 3. Add the digits, 12 plus 6 is 18, that's a multiple of 3. Yeah, it's going to be generating many less numbers beforehand because we're going to hit a lot more multiples of 3 than we did multiples of 10. Okay, so that's working. And then, we could do the same idea where we, let's look at our code here. We override the method with a default. So here, multiples of got modified to accept the divisor, and then we run it until it finds and returns a multiple of that divisor. So we could have another method with the same name. Without any parameters. That returns the method multiples, sending it the divisor of 10. Multiples. So let us look at that for a second, think about that logic. When you call multiples 10, you're saying I'm going to call this method, and it's going to return the first randomly, it's going to run this, print the random numbers until we get one that's a multiple of 10 and then return it. So when it returns that number n here is the value of this method. It's getting returned, and now we're returning that back to main. So here, if I just call, again, multiples, I guess we would need to do the same thing with output results as well. We'd have to have a default output results here. That only accepted one parameter, integer n, and that called output results sending n and the default value of 10. So what I'm doing is sort of setting up this overriding structure where the default values are 10, the default divisor is 10. So then I can call output results without a divisor here. So even with a divisor of 3, if I run this, because I'm not sending 3 in, I'm just doing it with multiples of 10, we get our original main method back. an interesting problem to think about, I was going to code this, but I think I'll switch over to something else, would be a slight modification on this. So I'll go back to show you the code again, and if you need to pause it to see all the code, you can. You don't really need main because main's just calling these functions. We really want to see the 2 versions of multiples and the 2 versions of output results. And there they are. Again, I'll save all 3 of these multiples of 2, and multiples of 3. I'll upload those to the in-class code page and think about this other modification. So I said that multiples of 3's, if you add the digits of a multiple of 3, if you add the digits of a number and the result is a multiple of 3, then the original number is a multiple of 3. So we could write a new program, or we could think about this idea that ask the user to input a number, determine if it is a multiple of 3, then demonstrate that this rule is true. In other words, show that the sum of the digits is also a multiple of 3. You know, this is an interesting little problem because it involves what we just did, but then how do you find the sum of the digits? So that involves sort of modular division by 10, 100, 1,000 to figure out what's in each place value. And then you can add those numbers up and then test if that number is a multiple of 3. So I don't think I'll do that example. Maybe I will in another video. But you could work on it. It'd be fun.